Hello everyone, in this lecture of physical pharmaceutics, we will study the surface area and specific, what is surface area, what is the specific surface area and how will you determine the surface area of powder particles. Surface area is the fundamental properties of powder. In the our previous lecture, we already studied some fundamental properties. For example, we have studied the particle size. Particle size is also fundamental property of the powders. Second fundamental property is the particle size. Particle size, surface area and specific surface area. So, first thing is what is the difference between surface, specific surface and specific surface and surface area and specific surface area. So, surface area, when we are saying the surface area of that much of particles, but when we are saying that the surface area of a 1 gram of or of a unit quantity, then it is known as the specific surface area. So, surface area is a property of solids defined as the total surface area that in the form of a unit is square of a material. It is a physical value that can be used to determine the type and properties of the material. Specific surface area is a specific area of a material per unit of a mass and that unit is m square per gram. So, if we determine the surface area of a unit quantity, then it is known as the specific surface area. That surface area and specific surface area have a same relation as the amount and concentration. So, determination of the surface area, how will you determine the surface area? There are two methods for the determination of surface area. One is the gas adsorption method and second one is the air or gas permeability method. So, in this lecture we will discuss the gas adsorption method for determination of the surface area. So, in this experiment of in a sample cell we just fill the 1 gram of a powder. So, that is why we are saying the specific surface area, we are determining the specific surface area because we have taken 1 gram of a powder. So, particle surface area increases as adsorption surface will also increase and subsequently there will be a more absorption of gases. So, for the determination of the particle surface area by gas adsorption method, there is one theory used for this purpose is known as the BET theory, the Brunner, Emmett and Taylor theory. This is a combined alphabet from the three scientists who had invented this adsorption method for the determination of the powder surface area. So, BET theory is a rule for the physical adsorption of a gas molecules on the solid surface. There are two types of adsorption, physical and chemical. These are the surface made phenomena. But in case of the chemical adsorption, we can't dissolve them. But in case of a physical adsorption, whatever you adsorb on the surface of the solid particle, whatever the air you have adsorbed on the surface, solid surface particle, you can dissolve and condense this also. So, Brunner, Emmett and Taylor theory, these three persons developed a method to determine specific surface area of a material. Adsorb means what is stick on the surface. This is why it is finding the surface area, matlab whatever amount will stick in a surrounding of the particle, jitna amount उस particle पे adhere होगा वही उसका surface area होगा. Whatever the surface area the particle will have, that will be the only the adsorption site, that will only be the adsorption site for that gases or any fluid. In this method we are using the two terms, adsorbent and adsorbate. Adsorbent, that means the solid particles जिनका surface area आपको निकालना है, that is known as the adsorbent. Adsorbate is the gas or fluid which you are using, which you are going to adsorb in surrounding of that solid particle. So, adsorbate is a gas, adsorbent is the solid particle. What adsorbate you can use? Nitrogen is the most commonly used gases adsorbate for the surface probing by BET method. Other gases, for example, krypton and argon can also be used, but the most frequently used gas for the determination of the surface area by this BET theory is nitrogen. The specific surface area of a material is then determined by the physical adsorption of a gas. There are two terms, one is the absorption and second one is the adsorption. Absorption when somewhere something is reaches inside that particle. Adsorption is the surface phenomena, then it will adhere on the surface only and we can dissolve them also. So, the specific surface area of a material is then determined by the physical adsorption of a gas on the surface of the sample at cryogenic temperature, at the typically liquid nitrogen temperature, which is minus 196 degrees Celsius. In this method, in a surface area determination by bed theory or bed method, for the temperature to carry out this experiment is the temperature at which the used gas or the gas which you are using, either a krypton or the argon or the nitrogen, whatever gas you are using for the determination for the surface area by this bed theory or bed rule, you have to carry out the experiment at the temperature in which that particular used gas, the gas which you are using become a liquefied. For example, in case of a nitrogen, in a room temperature, nitrogen in a gaseous form. So, for that if we just start the experiment in the room temperature and then slowly it adjusts towards minus 196 degrees Celsius temperature, and at minus 196 degrees Celsius temperature the nitrogen gas will be liquefied. So, if you are using the krypton, so you have to carry out the experiment at the temperature at which the krypton become liquefied. If you are using the argon, this you have to use that carry out the experiment the temperature when this argon gas converted into its liquefied form. So, here we are using the nitrogen because it is the most commonly used gas, that is why we are keeping the experiment temperature is minus 196 degrees Celsius, because this is the temperature at which the gaseous form of nitrogen will be converted into its liquid form. So, बहुत minus temperature होते हैं, these are also known as the cryogenic. Cryo, that means cryo, ice, ऐसे temperature जो बहुत lowest temperature होते हैं, that are known as the cryogenic temperatures. So, bed theory is based on the several assumptions. To apply this bed theory for the calculation of the surface area, we have to just follow some assumptions also. And what are these assumptions for the bed theory? First assumption, adsorbent surface should be homogeneous. What is adsorbent and what is adsorbate? Adsorbate is the gas, adsorbent is the solid particles. So, adsorbent surface should be a homogeneous. Adsorbent, that means the solid particles. So, we have to spread the homogeneous uniform layer of that solid particle, first one. Neighboring adsorbed molecules do not interact. जो भी अगर आप गैस पर्ज कर रहे हो उसमें गैस मॉलिक्यूल्स जो इसके ऊपर एडहेयर होंगे, दैट गैस मॉलिक्यूल्स शुड नॉट बी इंटरेक्ट विथ ईच अदर. दिस इज द सॉलिड पार्टिकल्स, these are the solid particles and this is the adsorbate gas. So, these first assumption is the adsorbent surface should be a homogeneous. Second one is the neighboring adsorbed molecules do not interact. These neighboring adsorbed molecules do not interact. At saturation pressure, the number of layers become infinite. At saturation pressure, number of layers of adsorbate gas should be finite. It will be infinite. Adsorption occurs by multi-layer formation. जब infinite layer है तो multi-layer adsorption ही हुआ. So, adsorption occurs by the multi-layer formation. And last one, uppermost layer of gas is in equilibrium with the vapor phase. किसके vapor phase के? Vapor phase of the nitrogen. So, here the uppermost layer. अब infinite layer बनेंगी तो कभी ना कभी it become saturated. तो जब saturate होगा तो जो uppermost layer बनेगी adsorbate gas की, that is in equilibrium with the vapor phase. So, these are the several assumptions for the bed theory कि अगर आपको bed theory apply करके आपको determine करना है surface area, तो you have to just fulfill this criteria, you have to just follow these rules also. Sample preparation, how will you proceed for the determination of the experimental portion? First one, weigh out the solid sample. अगर आपने 1 ग्राम sample use किया है, weigh किया है, तो जो निकलेगा that is known as the specific surface area. If you have out the 2 gram, 3 gram or 4 gram, then it will be only simple surface area. Specific surface area is belong to the unit quantity. So, first is the weighing of the sample, solid sample. Second one, the sample is purified by degassing or vacuum conditions. Third, sample filled in a quantachrome, the equipment or the apparatus which is used for the surface area determination by bed theory, that apparatus is known as the quantachrome. So, sample filled in a quantachrome gas adsorption analyzer. Nitrogen gas is passed through the cell containing sample. Surface area of a material is then determined by the physical adsorption of the gas onto the surface of the sample at cryogenic temperature. That means, first you have to start the experiment at the room temperature. During the purging of the nitrogen, it will be in a form of a gaseous form. But slowly and slowly you have to adjust the temperature towards the cryogenic temperature of the gas which you have used. Next step, after the adsorption equilibrium, सैम्पल इज हीटेड. जब इक्विलिब्रियम में पहुंच जाएगा यानी कि अपर मोस्ट लेयर पर जब वो बिकम सैचुरेटेड, देन व्हाट यू हैव टू डू आफ्टर द एडजॉर्प्शन इक्विलिब्रियम, सैम्पल इज हीटेड टू रूम टेम्परेचर. अगर आप उसे दोबारा हीट करोगे तो जो गैसेस फॉर्म में जो लिक्विड उसमें एड्जॉर्ब हुआ है, जब उसे आप हीट करोगे देन इट विल कन्वर्टेड इनटू द गैसेस फॉर्म. जो गैसेस फॉर्म में आएगा तो उसे आप कंडेंस करोगे. कंडेंस करने के बाद एनालाइज करोगे कि हाउ मच अमाउंट ऑफ दिस गैस विल बी यूज्ड for the formation of the multi-layer as well as for the formation of the monolayer of the gas. So, after the adsorption equilibrium, sample is heated to room temperature and gas will be dissolved and its volume will be measured. So, this is arrangement for quantachome's gas adsorption analysis. इस क्वांटाकोम, दिस इज द सैम्पल सेल. इस सैम्पल सेल में देर इज this tubular type of a sample cell in which you have to fill the 1 gram of the sample, and here the analysis gas manifold, this is a pressure transducer to vacuum, and this whole assembly you have to start from the room temperature and slowly maintain the temperature towards minus 190 degrees Celsius temperature if the analysis gas is nitrogen. So, what we have to do is just fill the 1 gram of sample in the sample cell and purge the nitrogen gas, follow all the assumptions of the bed theory, and slowly shift the temperature of this quantascope towards minus 196 degrees Celsius, so that this nitrogen which is in a gaseous form here is converted into the liquid form. Now, how the adsorption will take place? See, the particles either may be porous or non-porous. Non-porous, the no issue, there is a no pores. If the porous, this is the porous particle, तो there may be particle बहुत छोटे छोटे पोर भी हो सकते हैं, उससे बड़े भी हो सकते हैं, उससे भी बड़े हो सकते हैं. तो बहुत छोटे पोर को बोलते हैं माइक्रोपोर. This is known as a micropore, this is known as a mesopore, this is known as the macropores. तो जब पार्टिकल पोरस पार्टिकल है और उसमें गैस पर्च की जाती है तो सबसे पहले माइक्रोपोर फिल होगा या मेसोपोर फिल होगा और मैक्रोपोर फिल होगा. सी, whenever you purge the gas, this is a micropore, this is a mesopore, this is a macropore. ये सब किस केस में है? जब पार्टिकल क्या है, पोरस है. अगर नॉन पोरस यानी कि एकदम सॉलिड इंटैक्ट पार्टिकल, कोई पोर ही नहीं है उसमें, तो क्या होगा, सीधे सीधे उसके सरफेस पे गैस एब्जॉर्ब होगी. यहाँ पर क्या, अगर पार्टिकल पोरस है तो सबसे पहले अगर आप इसमें गैस पर्च करोगे तो कौन सा एरिया सबसे पहले फिल होगा, जो छोटा होगा. यानी कि सबसे पहले माइक्रोपोर फिल होंगे, फिर यहाँ पर मीजोपोर फिल होंगे, तब इसके बाद जाके यहाँ पर आपके मैक्रोपोर फिल होंगे. सी, सबसे पहले फिलिंग कहाँ से शुरू होगी, सैचुरेशन इसका होगा, फिर इसका होगा और फिर इसका होगा. अगेन आप इसमें कंटिन्यू रखोगे गैस को पर्स करना तो सेकेंड लेयर बननी शुरू होगी, फिर अगेन कंटिन्यू ही रहेगा तो थर्ड लेयर बनेगी. लेकिन ये कब तक बनेगी, एक टाइम वो भी आएगा जब यहाँ पे सैचुरेशन प्रेशर पहुँच जाएगा. तो सैचुरेशन प्रेशर पर जब पहुँचने तक जो नंबर ऑफ ये लेयर्स होती हैं दैट बिकम इनफाइनाइट. दिस इज द वन एजम्पशन ऑफ द बेड थ्योरी. ठीक है. सो यहाँ पर फर्स्ट स्टार्ट द फिलिंग ऑफ द माइक्रोपोर, देन मेसोपोर, देन मैक्रोपोर. कभी एब्जॉर्प्शन शुरू होगा जब आप इसमें गैस पर्च करोगे क्वांटासोप में, जिसके सैंपल सेल में यू हैव टू फिल द 1 ग्राम ऑफ अ पाउडर. So when gas pores, a smaller pore, that means the micropore filled first by adsorbed gas, and micropore will be filled later on increasing relative pressure. As relative pressure increases, the adsorbed gas continue to cover the external surfaces, and it covers meso and macropore too with the monolayer of gas. And its volume of the monolayer will have to be established when the calculating or material particle size surface area. So for the determination of the particle surface area, what we need? We require this monolayer formation. We don't want to how much a volume of gas will be consumed for the formation of the multilayer. Why it is required? हमें इसकी ज़रूरत क्या है, हमें किस चीज़ की ज़रूरत है कि कितने गैस का वॉल्यूम की यूज़ हुआ इसका मोनोलेयर बनाने में. मोनोलेयर कहाँ अटैच हुई होगी, जो पार्टिकल का सरफेस है. तो फॉर द डिटर्मिनेशन ऑफ द पार्टिकल सरफेस एरिया वी हैव टू नो द व्हाट इज़ द वॉल्यूम ऑफ गैस विच इज़ रिक्वायर्ड टू मेक द मोनोलेयर. So initially first we start the temperature in the this experiment at the room temperature. Initially we increase the pressure and shift that this assembly towards this cryogenic temperature. So slowly and slowly there is a monolayer formation, then the multilayer formation, then become a vapor, this is saturation pressure, and in case of the saturated vapor pressure at the stage of equilibrium pressure, there will be a number of multilayer will be infinite. And then you will get the some sort of a image like this. Initially monolayer बनाने के लिए कौन सी layer gas layer चाहिए, this is red. When you again increasing the pressure, see this in the x axis, in a y axis this is adsorbed gas, in a x axis the relative pressure. Whenever you increase the relative pressure from 0.1 to 0.9, जैसे जैसे आप इसका relative pressure increase करते जाओगे वैसे वैसे यहाँ पे लेयर का बनना बढ़ता जाएगा, और एक टाइम बाद एक इक्विलिब्रियम प्रेशर आ जाएगा जब इसका वेपर प्रेशर सैचुरेट हो जाएगा, और उस समय के बाद से इसमें मल्टी लेयर का फॉर्मेशन होना इट विल बी स्टॉप्ड. सो सबसे पहले इसमें क्या बनेगा, मोनोलेयर. गैस को आपने पर्ज किया, मोनोलेयर बना. इसके बाद भी रिलेटिव प्रेशर बढ़ाते जा रहे हो, दूसरी लेयर बनी, then third layer, then fourth layer, then sixth layer, then multi-layer. But हमें क्या चाहिए? We need only this monolayer, volume of gas which is required to make a monolayer. Once the saturation pressure reached at adsorption equilibrium, we just reverse the process. क्या किया था हमने, पहले रूम टेम्परेचर पे स्टार्ट किया था, और धीरे 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 वी स्लोली वी वेंट थ्रू टूवर्ड्स देयर दिस देयर क्रायोजेनिक टेम्परेचर, जैसे -196 डिग्री सेल्सियस. व्हेनेवर वी रीच टू इक्विलिब्रियम प्रेशर, दैट्स एन इक्विलिब्रियम कंडीशन, वी जस्ट रिवर्ट द प्रोसेस. दैट मीन्स जो हम स्लोली 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 -196 पे गए थे, नाउ स्लोली स्लोली फ्रॉम 196 डिग्री सेल्सियस वी हैव टू रीच टू द रूम टेम्परेचर. So once the saturation pressure reached, we just reverse the process and start decreasing the relative vapor pressure, and gas will be dissolved, because it from a liquid form it start converting to this gaseous form, and will measure the amount of gas which is required to make a monolayer. सबसे पहले क्या था, क्वांटासोप आपने क्वांटासोप अपरेटस लिया, सैम्पल सेल ली, 1 ग्राम सैम्पल सेल भरा. सैम्पल सेल में सैम्पल को किस तरह से अरेंज किया, जस्ट लाइक द टू जस्ट फॉलो द एजम्पशंस ऑफ द बैट थ्योरी. वी हैव टू मेक अ मोनोलेयर, वट एवर द पार्टिकल्स, नेबरिंग पार्टिकल, एडसॉर्बेट गैस मॉलिक्यूल विल नॉट इंटरेक्ट विथ ईच अदर. एट सैचुरेशन प्रेशर देयर विल बी अ मल्टी लेयर. आफ्टर दैट whenever the after the formation of the multi layer there will be the equilibrium condition. So after just fulfilling all these criteria, all these assumptions of the Bethe equation, फिर क्या किया हमने, धीरे धीरे उस एक्सपेरिमेंटल कंडीशन को टूवर्ड्स शिफ्ट किया टूवर्ड्स क्रायोजेनिक टेम्परेचर. किसके क्रायोजेनिक टेम्परेचर में, नाइट्रोजन यूज़ की थी तो नाइट्रोजन के क्रायोजेनिक टेम्परेचर में, जिससे कि जो गैसेस फॉर्म है नाइट्रोजन का विच विल बी कन्वर्टेड इनटू द लिक्विफाइड कंडीशन. जब लिक्विफाइड कंडीशन में पहुंच गया, इक्विलिब्रियम अटेन हो गया, सैचुरेशन प्रेशर हो गया, मल्टी लेयर फॉर्मेशन हो गया. नाउ वी हैव टू जस्ट रिवर्ट द कंडीशन. कैसे रिवर्ट करेंगे, जो -196 में था उसको हम धीरे 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 वी कम टूवर्ड्स द 25 डिग्री सेल्सियस टेम्परेचर, दैट इज़ द रूम टेम्परेचर. तो जो भी चीज़, जो भी गैस उसमें एड्जॉर्ब भी हुई होगी, जो -196 डिग्री सेल्सियस टेम्परेचर तक जाने तक, जब आप उसे कंडीशन को रिवर्स करोगे तो वो धीरे धीरे क्या होगी, डिज़ोल्व होना शुरू करेगी, और जो जो गैस डिज़ोल्व होगी उसे आपको कंडेंस करना है. So this is the this red process which is from starting from the in the gas adsorption process. Red blue process is this green. This process is for the gas adsorption process and this is the gas, red one is the gas desorption process. तो पहले क्या स्टार्ट हुआ था, गैस का एड्जॉर्प्शन. तो ये पार्टिकल है एंड यू कैन सी दिस पार्टिकल इज द पोरस पार्टिकल. अगर नॉन पोरस बनाना होता तो हम कैसे बनाते हैं नॉन पोरस पार्टिकल, बस दिस इज द नॉन पोरस, कोई पोर नहीं है. अगर पोरस बनाना है तो इट्स विल बी लाइक दिस ना, पोर, क्रैक्स. दिस इज ऑल्सो नोन एज द इंट्रा पार्टिकल स्पेस. सो जो इसका इंट्रा पार्टिकल स्पेस है, जो क्रैक्स हैं वो पोर्स हैं, कुछ पोर्स छोटे होंगे, कुछ बड़े होंगे, कुछ उससे बड़े होंगे, इसलिए इन पोर्स को हमने मीज़ोपोर, माइक्रोपोर और मैक्रोपोर में डिवाइड किया हुआ. माइक्रो सबसे छोटे, मीज़ो इन बिटवीन एंड मैक्रो उससे बड़े. तो जब भी फिलिंग शुरू होगी इसमें, यानी गैस का एड्जॉर्प्शन शुरू होगा, तो सबसे पहले जो एरिया कम है वो जल्दी सैचुरेट होगा. तो सबसे पहले कहाँ पर गैस एड्जॉर्ब होना शुरू करेगी, माइक्रोपोर में, फिर मीज़ोपोर में, फिर मैक्रोपोर में, और अल्टीमेटली पूरा पोरस पार्टिकल जिसमें मोनोलेयर बन जाएगी. और फिर भी हम उसका रिलेटिव प्रेशर बढ़ाते रहेंगे तो अल्टीमेटली दूसरी लेयर बनेगी, फिर थर्ड लेयर बनेगी, फिर फोर्थ लेयर बनेगी, एंड आफ्टर दैट इट विल बी अ मल्टी लेयर फॉर्मेशन. जो वाइट लेयर देख रहे हो दैट इज़ द मल्टी लेयर फॉर्मेशन, और जो ब्लू लेयर है दैट इज़ फॉर द मोनोलेयर फॉर्मेशन. जब मल्टी लेयर बन जाएगी, नाउ वी हैव टू जस्ट रिवर्ट द कंडीशन. कैसे रिवर्ट करोगे, अब जो -196 पर ले गए थे इसे फ्रॉम रूम टेम्परेचर, इसको हम धीरे धीरे रिवर्ट करेंगे इधर. तो जब आप इसको -196 से टूवर्ड्स रूम टेम्परेचर लाओगे तो डिजॉर्प्शन होना शुरू होगा. जो भी गैस एड्जॉर्ब हुई होगी दैट विल बी डिजॉल्व. So here you will condense the gas, whatever the amount of volume of the gas which will be dissolved here, and after this we can also determine the volume of the gas which is required to make a multi-layer and volume of gas which is required to make a monolayer. And this is the volume which is required to make the monolayer. That volume will be used for the calculation of the surface area. And since this is the curve, this desorption curve may overlay or appear to the left of the adsorption curve. So if you draw the adsorption curve, in a x-axis we have to take the relative pressure, in a y-axis amount adsorb or amount dissolve. So in case of when we are going heading from the room temperature towards -196 degrees Celsius, then there will be this curve, upward curve, and during the revert condition, that is known the desorption or a downward curve. So downward curve may superimpose this upward curve, that means the adsorption curve. The desorption curve may superimpose the adsorption curve or may shift towards the left. So here in this picture, in this diagram, it is shifted towards left side. This is shifted towards left side. अगर इस पे सुपर इम्पोज करते तो how will you make this upward adsorption curve, and this is again desorption curve. This will be same, but here the curve is somehow shifted towards the left side. Now what is the formula to determine the surface area? For this is the BAT equation, and this is somehow equivalent to y equal to mx plus c. In this BAT equation we will determine or we will know the volume of Vf, volume of gas required to form a monolayer. So जो BAT इक्वेशन है, जो हमने अभी एक क्वांटस ऑफ इंस्ट्रूमेंट यूज़ किया, पूरा एक्सपेरिमेंट रूम टेम्परेचर से उसके क्रायोजेनिक टेम्परेचर तक ले गए, उसको रिवर्ट करके लाए, गैस कितनी डिज़ॉल्व हुई उसको मॉनिटर किया, कितनी गैस मोनोलेयर बनाने के लिए लगी, कितनी गैस मल्टी लेयर बनाने के लिए. वी ऑल डिड दिस ऑल थिंग्स जस्ट बिकॉज टू डिटरमाइन द वॉल्यूम ऑफ गैस विच इज़ रिक्वायर्ड टू मेक द मोनोलेयर. by putting these data, that the saturation pressure, vapor pressure, all these, this is constant, by putting all these parameter or by putting all these data into this BET equation, this is known as the BET equation. By putting this data in the BET equation, we will get the volume of gas required to make a monolayer, and when we will get this volume Vm, we put this Vm in the calculation for the surface area determination. So, in the this is known as the BET equation. From the BET equation, we will what is the application of BET equation? BET equation will give the idea whatever the amount of the gas which is required to make the monolayer Vm. Now, this is the formula to determine the specific surface area. अब specific क्यों कह रहे हैं? Because we are using the 1 gram of powder. This is unit quantity. That's why it is a specific surface area. So, specific surface area is equal to A Vm into N divided by M by D. Here see, only Vm is the unknown, here which we do not know. So, Vm we can calculate from the BET equation, this from here we can calculate the Vm, volume of gas which is required to make a monolayer. SW is the specific surface area which we are going to determine. A is the molecular cross sectional area of the adsorbate gas, that is for nitrogen, it will be fixed. N is the Avogadro number, it is also fixed value. M by D is the molar volume of the adsorbate gas, for the nitrogen it will also fix. So, M by D, this is belong to the nitrogen, this belong to the nitrogen, this belong to the nitrogen, and this is also belong to the nitrogen. This is the volume of gas which is required to make the monolayer, but these are the fixed value. तो वे वैल्यू आपको as such इस फॉर्मूले में रखनी है, but this Vm, this is the unknown which we have determined from the that BET equation. What is the BET equation? कैसे BET equation से निकाला? By using Quantasov instrument. So that we have to put that Vm which we obtained from here, we put this Vm here, and then we will get the form specific surface area of the powder. Now, application of the BET principle. What are the different application of the BET principle? By using this BET we can determine the specific surface area, and by using the specific surface area you can also analyze the absorption of this API or absorption of the drug molecules in your body. If the more the surface area, more will be the absorption. Advantages of the quantachrome, that instrument which we have used for the determination of the particles surface area by this adsorption method, that was the quantasol. So, the quantachrome, it is a versatile in the sense that it permits the use of a number of gases. You can use the single gas or you can use the mixture of gases in this quantasol instrument, as a quantachrome is a type of a quantasol instrument. So, in a quantachrome you can use either a single gas or a mixture of gases over a range of temperature, because for the this cryogenic temperature for nitrogen is different from the cryogenic temperature of argon, which is automatically is obviously different from the this third gas, that was the argon. So, it allows the evaluation of characteristics of porous as well as non-porous particles. So, this is used for the surface area determination of the porous particles as well as the non-porous particle. Non-porous, there is a no intraparticle space, porous there will be intraparticle space. So, this is all about your surface area determination by air adsorption method under the theory which is applicable for this. This is the Brunner, Emmett and Taylor theory. This is also known as the BET theory, and the Quantasov was the instrument, and by using Quantasov we can determine the Vm, volume of gas which is required to the monolayer, and we have to put the data of Vm in the surface area determination formula, and in this way we can determine the surface area of the powder. So, this is all about for the surface area determination by air adsorption method. Thank you.